Welcome back to the Explainer. So, today we are going to crack the code on two incredibly important concepts in chemistry, the atomic number and the mass number. Now, if you've ever looked at a periodic table and just felt this overwhelming wave of confusion wash over you because of all these numbers, trust me, you are absolutely not alone. They show up on literally almost every single chemistry exam, yet they are one of the biggest pain points out there. I mean, they sound kind of similar, but they represent completely different things. By the end of this explainer, I promise, you are going to have absolute clarity. You'll know exactly what they mean, how to calculate them, and really how to tackle any question thrown your way with total confidence.
Okay, let's dive into this. Here is our roadmap for today. We'll cover the atomic number, then the mass number, finding the neutrons, avoiding those common mistakes, and finally, we'll test your knowledge with a quick quiz.
All right, part 1, the atomic number.
Let's start right at the foundation, establishing absolute clarity on our first building block. The atomic number is simply the number of protons in the nucleus of an atom. And honestly, I literally cannot emphasize this enough. This is the absolute most important number you're going to deal with. Why? Because it essentially identifies the element. The number of protons is the exact thing that makes an element what it is. To really lock this in, let's run through a few quick examples. Hydrogen has exactly 1 proton, right? So its atomic number is 1. Carbon has 6 protons, making its atomic number 6. Oxygen has 8 protons, so naturally, its atomic number is 8. You can think of the atomic number as an element's ultimate fingerprint. Now there's also this really crucial neutral atom rule we have to talk about. In a neutral atom, everything balances out perfectly. The number of electrons is always going to equal the atomic number. So looking back at our oxygen example, since it has an atomic number of 8, a neutral oxygen atom has 8 protons, and that balances out perfectly with exactly 8 electrons.
Moving right along to part 2, the mass number.
Okay, so you've mastered the first number. Now let's introduce the second one. Actually, just for a second, put the atomic number in a totally separate box in your mind. We really want to keep these concepts distinct to prevent any cognitive overload. So here's our second definition. The mass number tells us the total number of particles inside the nucleus. Think of it like this. If you were to magically shrink down and step right inside the nucleus of an atom, you'd be counting both the protons and the neutrons together to get this grand total. And putting these head-to-head brilliantly illustrates how these two easily confused concepts differ. With the atomic number, you are measuring only the protons, and, the electrons if it happens to be neutral. But with the mass number, you're measuring the total heavy particles clustered in the center, so protons plus neutrons. Take carbon-12, for example. We know carbon's atomic number is 6, which means 6 protons. But carbon-12 also happens to have 6 neutrons. You just add those 6 protons and 6 neutrons together, and boom, you get a grand total mass of 12. Which brings us to part 3, finding the neutrons. So we have the protons, and we have the total mass. Now it's time for the missing link of the whole lesson. How do we actually connect these two numbers to find that invisible third variable, the neutrons? Well, if you know the atomic number and the mass number, finding the neutrons is incredibly simple. It's just a foolproof 3-step formula. Step 1, identify the mass number, which is your big total. Step 2, identify the atomic number, which is just your protons. And step 3, just subtract the atomic number from the mass number. Let's walk through this using a sodium atom. Sodium has a mass number of 23 and an atomic number of 11. To find the neutrons, we just subtract 11 from 23, and that reveals exactly 12 neutrons. So our sodium atom contains 11 protons, 12 neutrons, and, because it's neutral, 11 electrons. Let's actually see how this builds using some real exam-style examples. First up, magnesium. It's got an atomic number of 12 and a mass number of 24. How many protons? 12. How many neutrons? Well, we take our mass of 24, subtract our atomic number of 12, which gives us exactly 12 neutrons. And electrons? Since it's neutral, it matches the protons perfectly at 12. Now, let's look at chlorine. Atomic number 17, mass number 35. Protons are 17. For neutrons, we just subtract 17 from 35, leaving us with 18 neutrons. And the electrons? They perfectly mirror the protons at 17. As you can see, this formula just works perfectly every single time.
Let's move to part 4, avoiding common mistakes. You've got the math down perfectly now, but let's pivot to a bit of a defensive strategy here, so you can confidently dodge the most common traps they set for you in chemistry exams. I want to mentally cement these major pitfalls in your mind right now, way before you ever sit down for a test. Mistake number 1 is simply confusing the atomic number with the mass number. Remember, atomic is just protons, mass is protons plus neutrons. Mistake number 2 is forgetting that the atomic number strictly and only represents protons. And mistake number 3, and wow, this one trips up so many people, is trying to add electrons into the mix when calculating the mass number. Don't do it.
So the crucial point is captured beautifully right here. Electrons have a very tiny mass and are not included in the mass number. They are just so unbelievably light compared to protons and neutrons that their weight essentially doesn't even count toward the total mass of the atom. You just completely ignore them when calculating mass.
And finally, part 5, test your knowledge. All right, you've learned the rules, you know the formulas, and you know the traps to avoid. Let's transition into an interactive, rapid-fire quiz to test your brand new skills in real time. I actually want you to shout the answers out at the screen. Here's question 1. Read the scenario carefully. An atom has 15 protons and 16 neutrons. What is its atomic number? I'll give you a second to think.
Boom! It's 15. Remember, the atomic number strictly equals the number of protons. If there are 15 protons, no matter what else is there, the atomic number is exactly 15.
Let's keep this momentum going. We're looking at the exact same atom. 15 protons, 16 neutrons. What is its mass number? Do that mental math real quick.
31. You got it. You simply add the 15 protons and the 16 neutrons together to get your total mass inside the nucleus. Fantastic job.
Okay, here is your final, slightly harder challenge. An atom has an atomic number of 20 and a mass number of 40. How many neutrons does it have? Take a moment and think it through.
It's 20. Huge congratulations if you got that one right. You correctly took the total mass of 40, subtracted the 20 protons, and found the remaining 20 neutrons. What a totally triumphant end to the quiz.
Now, what's really interesting about this recap is that these 3 easy formulas are literally the only tools you need to solve almost every single question on this topic. Seriously. Atomic number equals the number of protons. Mass number equals protons plus neutrons. And the number of neutrons equals the mass number minus the atomic number. Just commit these golden rules to memory, and you're going to be completely set. But before we wrap up this explainer, I want to leave you with a bit of a mystery to ponder. If the atomic number dictates exactly what the element is, how can 2 atoms of the exact same element, meaning they have the exact same number of protons, somehow end up having completely different masses? I mean, how is that even possible? Well, that fascinating puzzle has to do with something called isotopes, and it is exactly what we're going to be diving into next time. Thank you so much for joining me today. I really hope this cleared up the confusion and made learning these concepts a bit more enjoyable. Keep studying hard, and I'll see you all in the next explainer.